Hi, everyone. Let's simplify this kind of monstrous looking thing here. 3 over negative 2x squared all to the negative 4. We want to simplify this expression, make it look nicer. And we want only positive exponents in our final answer. So non-positive exponents, that is exponents that are negative or 0, are not allowed in the final expression. So if you have exponents in your final answer, they better be positive. All right. Now, first off, I don't like the fact that there's a negative exponent up here. So how can we rewrite this expression as something equivalent where we have a positive 4 as the exponent? What do we need to do to turn the negative 4 into a positive 4? We have to take the what of the base here. We have to take the reciprocal of the base here. And that's this rule over here. Number 8. If you have a fraction raised to a negative exponent, you can change that to a positive exponent if you take the reciprocal of the base. So the exponent goes from negative 4 to positive 4, but we have to take the reciprocal of the base. Okay. Take the reciprocal of the base. Okay. If you're going to take the opposite of the exponent. By the way, right off the bat, there's a hidden restriction. 0 is an illegal value for x over here. We should technically note it over here. But usually what we do is we save it for the end. Okay. So when we note the restrictions, the domain restrictions at the end usually. But technically, we have a hidden restriction right here. When you pull a stunt like this, you might end up hiding restrictions. Things involving reciprocals, negative exponents, things like that. All right. Now, and different students might perform the operations in a different order, okay? But we basically have a quotient or a fraction being raised to a power or exponent. This exponent can be shared, all right? That's basically rule 5, okay? If you have a fraction raised to an exponent, the top and the bottom share the exponent. The hidden restriction note over here. All right, so we have, so this up here, it's the top to the 4th over the bottom to the 4th. So we have I'll make this bigger here, all right? Negative 2x squared all to the 4th over 3 to the 4th, okay, with this hidden restriction. And then over here, we have now the power of a product raised to a power or exponent. Again, like with the quotient, we share the exponent across the factors. Remember, we need grouping symbols around the negative 2. Okay, because if you just write this, it turns out you're going to be wrong. All right, so don't do that. Okay, so it's the 4th power of negative 2 times the 4th power of x squared over, and then 3 to the 4th is 81. Okay, what is 3 times 3 times 3 times 3? What's 3 to the 4th? Well, 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. All right. All right. Now the 4th power of negative 2, all right? Well, the 4th power of a negative number is positive, all right? You can even break this up further as negative 1 to the 4th, okay, times x squared to the 4th. Whoops, I'm sorry. Times 2 to the 4th, okay? So if you're concerned about the 4th power of negative 2, you could write it as the 4th power of negative 1 times the 4th power of 2, okay? The 4th power of negative 1 is just 1, all right? 2 to the 4th is 16. 2 times 2 times 2 times 2. Similar logic here. All right. Now, the 4th power of x squared. When you raise a power to a power exponent, what do you do to the exponents? That was rule number 3 here, law number 3 here. You raise a power to a power or exponent, you multiply the exponents. 2 times 4 is 8. So we have 16 x to the 8th over 81. And this is simplified because remember, 16 is 2 to the fourth, 18 is 3 to the fourth. There are no good factors in common. By good factors, I mean anything besides 1 or negative 1. So we cannot reduce 16 over 81. But remember, we have the hidden restriction. Don't forget that 0 is illegal for x. If 0 is illegal for x over here, and it was, because it would lead to a division by 0, then 0 is still illegal. But since it's a hidden restriction, it's not evident, we really should write it. So this expression here, I'll put this in green, this expression here is equivalent to this expression here, together with the hidden restriction. All right.